Welcome all, magandang gabi, and welcome to the year of the water snake. Happy New Year. My name is Joel Tan, and I'm the Director of Community Engagement here at YBCA. I'm extremely excited about our partnership with the Long Now Foundation, our muse of ideas and culture. And with complementary missions, YBCA and Long Now often partner to present rich, out-of-the-box, diverse, dynamic programs that address issues affecting us today.
Sorry, this is a slightly longer introduction than most evenings. We have a few of us. So I'm Alexander Rose, the director here at Long Now. As many of you know us as the organization that puts on these speaking events, but actually what Long Now started as was a maker organization. We started with the idea of building a 10,000-year all-mechanical monument-sized clock designed by Danny Hillis, who's here tonight. I came onto the project in 1997. We finished our first prototype in 1999. That one's at the Science Museum in London. It was about 8 feet tall. And since then, we've been working on the full-scale version, and there's been very little released about it because we didn't want to release anything until we had something really done. But tonight, for the first time ever released to the public, you're going to see some of the first machinery that's been completed on the clock. This stuff was machined up in Seattle for the most part and assembled here in the San Francisco Bay Area in our shop in San Rafael. And the video you'll see are the very first testing of a 10,000-pound weight system for the 10,000-year clock. It's all stainless steel and ceramic unlubricated bearings. Thanks.
Talk about small batch manufacturing. We got a product run of 1. There's some distribution issues in that getting it to the customers will be hard when it's in a mountain in West Texas. So we'll have to get the customers to it, but that could happen later in this decade. Good evening. I'm Stuart Brand from the Long Now Foundation. Chris Anderson, I always thought of as kind of as an economist. He was a journalist at The Economist magazine, but he's a journalist. So he has this nose for news. And then he got to be editor at Wired and still doing economic stories, but as an editor, he didn't have to sniff out the news anymore. He got to decide what was news. And then he went the level deeper that all journalists really want. I don't want to just report the news. I want to make the news. That's what Chris Anderson's doing now. Please welcome him.
Thank you, Stuart. This is a big deal for me. I am a huge Long Now fan, and every day in the car I listen to the SALT lectures on the podcast, and I can tell you there is no faster way to get smart than Long Now lectures at 1.8x. It's also very intimidating because the sort of idea density is just extraordinary in these. And this is especially a big deal because Stuart and Kevin Kelly and Peter Schwartz, who I think of as kind of a triumvirate who are all here tonight, are my intellectual heroes and mentors. And I feel that I couldn't be here if it hadn't been for them and everything they've stood for. So thank you, Stuart, for everything you've built. So tonight I'm going to talk about three things. I'm going to talk about industrial revolutions and why they're a big deal. I'm going to talk about, inspired by the Long Now motif and mission, I'm going to talk about the long arc of history and how perhaps 1,000 years of history, the direction of 1,000 years of history, is about to reverse. And then I'm going to talk about the maker movement and why something that may seem trivial and hobbyish is potentially a bigger deal than even possibly the internet. Let me start by just sort of talking about industrial revolutions. The subtitle of my new book is The New Industrial Revolution. I spent some time sort of relearning about industrial revolutions, and I was surprised by a couple things. First of all, the first industrial revolution, which we think of as being, largely the dark satanic mills and all that, actually began much earlier than I had realized. It began in the same year as the American Revolution, 1776, with the first commercialization of the spinning jenny, which was essentially the simplest possible parallel processing machine for manufacturing. The spinning wheel dates back to medieval times, and you see it in fairy tales. And the spinning jenny is really just a parallel processing wheel. It's where you spin multiple threads at the same time. And it was originally powered by the foot, and this led to the cottage industry of the late 18th century. And then after the foot, it was powered by horses, and after horses, it was powered by wheels, water wheels, and after that, it was steam and then electricity. But fundamentally, this was a game changer. This single thing, the spinning jenny, changed the nature of production. It allowed people to make more clothes than they could wear, and so they become producers. It allowed them to increasingly move off the land as the source of their sustenance, and it emancipated many women by allowing them to create small businesses in the home in these cottage industries. It built family-oriented businesses. Now, very quickly, these became feeders into much bigger factories, which were driven, again, by the quest for more motive force. The foot power could only take you to maybe 6, 10 of these wheels. Horses could maybe take you to 10 or 12, but then you needed to go to a water wheel, which meant you needed to move to the rivers and to the creeks. And then you needed even more power, and you'd move to steam, and that took you to the cities. And that created modernity. And when you think about those early days of the Industrial Revolution, initially what we think of is the sort of the worst of it, the belching smokestacks, the crowded living accommodations, the dark factories. But what fundamentally it did is it moved people off the land and concentrated them around cities, which is a big theme of Stuart's work. And when you concentrate people to the cities, when people move to the machines, rather than the other way around, as we've done with the mechanization of farms, when people move to the machines, you end up with a density that you otherwise wouldn't have. And with that density comes the need for the infrastructure of modernity. The sewage system, running water, schools, transportation, better housing, etc. And one of the really fascinating things about this move is what it did to the human condition. We think of the factory town as being less healthy than the farms, than the bucolic countryside that these people left. But the reality is that although initially they were a little dark and overbuilt and not so nice, what you quickly realized is that when you build the infrastructure of modernity and things like schools and healthcare systems and clean water systems, people suddenly got healthier. And those cottage walls were damp, and the brick walls were not. And you didn't have access to schooling in the small village, and you started to as they built the infrastructure around the factories. And this is what it did. It doubled life expectancy. The concentration of humanity around the machines, around the means of production, ended up building something that was better for us, at least better for our species in terms of life expectancy. And this is what it did to the population of England and Wales in that time. And this is what it did to the world. This is a graph I got from Andy McAfee, and it's really kind of profound. This is sort of the long arc of human history. This goes back, to 2000 BC. And basically, when you measure it in terms of things like population and, quality of life indices, nothing happened until the Industrial Revolution. So the Roman Empire, Muhammad, Jesus, Plato, Greeks, the Egyptians, it's all kind of unmeasurable when you look at these sort of core measures of kind of a species success, which is their ability to live longer and reproduce more. Now, arguing whether that is a good thing or not is I'll leave for another lecture, but the point is it was a game changer. It actually kicked in slightly before the Industrial Revolution, largely due to the mechanization of agriculture. So you can call that a proto-industrial revolution on the farm. But it was really once we kind of started to amplify human potential, to replace muscle power with machine power, that we were able to move to the next level of progress and development as a species. And this is seen by those metrics, there's really nothing that changes the game like replacing muscle power with machine power, of letting us kind of move up the evolutionary ladder from our kind of undifferentiated limbs to our highly differentiated brains. So that's the first industrial revolution. It was a machine revolution, and it was about allowing us to go from beasts of burden to beasts of brain. The second industrial revolution, by the way, there's lots of argument about how many industrial revolutions they've been and whether the assembly line counts as one and, whether steam is different than water, et cetera. But I'm going to just kind of move quickly past that and say, kind of in the long arc of history, the next industrial revolution should be the digital one. But I'm not going to show a computer. I don't think it's about computers. Now, the computer, this is the 1940s or the 50s, et cetera, but I don't think the computer was really what made the digital revolution a big deal. Instead, I think what made it a big deal was the democratization of that. And I'm not, again, showing a personal computer, although I could, but it was fundamentally the giving of this means of production to everybody. It was the spread of computing to non-professionals, to regular people, that changed the game because it didn't just replace brain power with machine power, but it allowed brains to work together. It unleashed these sort of spare cycles, this sort of dark energy of cognitive surplus, to use the phrase, that was just sitting out there waiting to be connected. And so what I've used here as an analogy, I'm going to come back to this as we move back into manufacturing. What I've used as an analogy is something that you probably have forgotten about as a big deal. This was the release of the first laser printer. This is the Apple Laser Writer from, I believe, 1986. I'm sure someone here will be able to correct me. I think it cost about $6,500 when it was released. But with it came this thing called desktop publishing. And I realize that desktop publishing is not a mind blower anymore, but it was at the time because it did an amazing semantic trick, which is that it took an industrial act called publishing, which used to be done in a factory called a printing plant, and it just added the word desktop in front of it. We took an industrial act and we made it personal, desktop publishing. And the means, the mechanism of how this was done was kind of interesting at the time. It was the laser printer was a high-resolution printer, but more to the point, it spoke a language called PostScript. And as a matter of fact, that first laser printer, which came out a year after the Macintosh, had more processing power than the Mac itself, because parsing this language of industrial printing was so complex. But what's interesting about this language, PostScript, is that it was what we call scale-free. That same language drove the printer on your desktop and also the biggest industrial printing plants in the world. That you could prototype something on your desktop and then upload it, or I guess in those days, put it on a floppy drive and carry it, to a printer where it could be made in any volume. And now you had the ability to slightly harness professional tools personally. Now, again, it was expensive and it was a little hard to use, but the other element was the software. That desktop publishing software was available for everybody. And you didn't need, 500 years of sort of printing technology dating back to Gutenberg, and these terms of arts and these skills now were just a point-and-click experience. And yes, we made a dog's breakfast of pages, mishing together fonts and horrible things, but we quickly learned. We learned about leading and kerning and wraparound and flow, and all those terms of art became something that became almost second nature. But that only allowed us to make a few. No one was going to compete with the New York Times with a laser printer. And then we democratized the other necessary step. Not the tools of prototyping, but the tools of distribution, and that was the web. And the web allowed you, by transmitting digitally, to again break through the barriers of scale. Now everybody could reach the world's population. The barriers to entry had fallen to zero. It was again a scale agnostic method, and it did not discriminate between the professionals and the amateurs, between the credentialed and the uncredentialed. It didn't discriminate between businesses and regular people. It didn't discriminate between the good and the bad. It was an indiscriminate distribution system, and that liberated creativity, and that's where we find ourselves today. And, I think, we forget how magical the moment we live in. Everyone in this room has clicked a button that says published and potentially reached 8 billion people. And the fact that, something that used to be a factory, something that used to require professionals, unionized typesetters to do is now a button in your browser is kind of magic, and I forget to kind of marvel when I push that button, but yet we should. It is kind of an extraordinary thing that we've taken, what Marx would have described as the means of production and basically made it something that is available to everybody and that we all have the same power. Now, whether your words are going to be read or picked up or go viral is another matter, but the fact is we all have the same means of production. So that's the power of democratization. That's why I think that it's not about the technology, but more about who's using it. And the power of the digital revolution is that it let everybody use it. It was agnostic as to the credentials required to use it, and you didn't need any. And so fundamentally, it opened up a huge pool of talent and energy and ideas and context, and I don't need to say anything more about it. It created the web. So that's what the second industrial revolution did. Now the third. So the third is the combination of the first two. It's manufacturing and digital. It's digital manufacturing. And once again, this is not super new. Factories have been digital for decades. And that's not the breakthrough. That's great, and it's been it's been good for productivity, and we have our iPhones, so thank for that. But just as it took, say 30, 40 years for the mainframe to turn into the personal computer, we've waited that long for digital manufacturing to become personal, for digital manufacturing to become democratized. And so the full potential of the digital element can now be realized. So we talk a lot about, so the fact that factories are automated is not a big deal. It has been true for a long time. And I think, let me quick show of hands. How many people here got to visit the NUMMI factory down in Fremont? So Kevin, I know you did. You had a fantastic tour of it. So a small number of you did. This was the gold standard of 20th century manufacturing technology. I'm sorry, that's the best picture I could get. But it was a collaboration between Toyota and GM to basically take the Japanese lean manufacturing methods, bring in the state-of-the-art of sort of 1990s, automation, and create a factory of the future. There's a really good, by the way, I think This American Life, I think it's an NPR This American Life that was sort of talked about what went wrong. But suffice to say, it closed down, and it turned out that it just wasn't flexible enough. It made one kind of car, or actually it was three kinds of cars, quite efficiently. But in the end, the marketplace demands wanted more flexibility, and I recommend the NPR history to hear more about it. But the point is simply that was 12 years ago. And then Tesla bought that factory, or basically got the rights to that factory for a song, and put in place another car factory. This is just 10 years later, but this is what the Tesla factory looks like. And if you get a chance to visit the Tesla factory right now in Fremont, you should, because not for nothing was Iron Man based on Elon Musk and his factories. This thing is unbelievable. But what you're seeing there looks superficially the same. You're once again seeing machines making cars. But the difference is that the NUMMI machines were custom. Each machine did one job. And they were extremely hard to program and very inflexible. And once you kind of got the whole factory up running and doing one thing, you kind of didn't want to change it. You just churned it out one after another. And every machine was different. The welding machines were different from the painting machines, which are different from the stamping machines, which are different from the sewing machines and the testing machines and the wheel applying machines, etc. What you're seeing here is that all the machines are the same. These are KUKA robotic arms from Germany, state-of-the-art robotic machines. But the point is that they're general-purpose robots. Every car can be different. And today they're making cars. They could be making washing machines on the same line. These robot arms have these racks of different tool heads. And they can change their function simply by going and grabbing a different tool. So they can be a welding robot, or a bolting robot, or a door-closing robot, or a wheel-applying robot. And there's hardly a person to be seen on the floor. And what looks like a subtle difference, single-purpose, specialized robots versus general-purpose robots, is actually transformative, because fundamentally what this allows is flexibility. And flexibility, I'm going to argue, is the key winning factor of the 21st century, because flexibility allows you to move faster, it allows you to operate in smaller batches, and it allows you to personalize. Every Tesla can be different. If you go to a BMW factory or Mercedes factory, any high-end car factory, they're all the same. They're all using these flexible manufacturing systems. So this is what digital manufacturing looks like on the industrial scale. And that's why this era of automation is different from the last one. But I'm going to go further than that. I want to show you a video, if I can just tab over here. And I want to show you a video of a robot at work. This is not sped up. That is in real time. And it's doing that little sort of a trick they do in the streets of New York, where they hide the bean under. And I just wanted you to kind of watch that and think a little bit about the human role in the world, human place in the world. It's kind of mesmerizing. So that's what robots can do today. They're really fast, and they're really accurate, and they're increasingly cheap. Rethink Robotics, Rodney Brooks' new company, has a Baxter which I'm not actually showing here. I probably should have. The Baxter robot costs $22,000. What's brilliant about it is that it's a torso with arms and a head. It's kind of human-sized. It comes on this little sort of wheeled platform, and you kind of imagine the use case. What's great about this robot, the Baxter, is that you don't program it. You reach behind it and you teach it, like you would with a child. And the scenario I have in mind, and this is probably not what Rodney has in mind, is that you go to your whatever your factory is or your bakery, let's say, and you're putting cupcakes in a box. You have an employee who puts cupcakes in a box, and you sort of think, a robot could do that. And so what you do is you buy a Baxter for $22,000, which is like less than an annual salary, and you wheel it in, and you tap the guy on the shoulder, and he turns up, and you ask him to move his chair over, and then you wheel Baxter in, and then you tell him that he's got 1 more hour of employment, and that his job over the next hour is to stand behind and show the robot how to do his job, and then you collect your severance if you're lucky on the way out. And it's a little scary, but this is kind of what's becoming possible. So what does this mean for the future of work? And what I'd like to argue is that this is going to reverse the era of globalization. And what I mean by that is that, globalization, and by that I mean sort of, the quest for cheaper labor. And this goes all the way back. This predates the Industrial Revolution. The quest for cheaper labor has moved us largely east, a little bit south, but largely east for certainly since the 1700s. The original, spice, the spice lanes, and that was a quest for resources. But then very quickly, once we began to manufacture things and move them around the world efficiently, we went for cheaper labor. And that took us largely to China, to India, other places like that. But when you see these robots, what you realize is that labor is increasingly automated. China's adding robots as fast as we are, and we all buy robots for the same price. And so what that means is that labor arbitrage no longer drives trade. The labor cost of products is a tiny fraction and shrinking every day, and as robots do the work, you don't see geographic differentiation. Labor arbitrage was a geographic quest for cheaper people, and now as you remove people from the equation, what's going to drive the arrow of globalization? What's going to decide where things are made? And I'm going to argue that it's time. I think we're going to make things where we can make them fastest. Stuart mentioned I just quit my job. In December, I quit my job as the editor of Wired, where I'd been for nearly 12 years, and took over as CEO of my robot company. You can sort of see where this is going. We make drones, which I hasten to add do not replace very many humans. They largely do jobs that aren't being done at all, which is putting cameras in the air. We'll save that for the question period. But we're based in San Diego, and we have a big factory in Mexico. And I live in Berkeley, and I decided to open an office in Berkeley. And this is where I opened it. I opened it at a furniture factory called Swerve on 7th Street. And I opened it just because I happened to know this guy, and he seemed kind of interesting. And I ended up being co-located with a furniture company. And when you visualize a furniture company, you're probably thinking of wood and labor and all that kind of stuff. Well, you can't make that kind of furniture in Berkeley. If you're making, and this furniture tends to be quite metal and relatively high tech, lots of Silicon Valley companies get it. But the way you make furniture in Berkeley is with this. This is a Fanuc arm, which loads a Morisiki CNC, a 5-axis CNC in the back. The machine in the back is, CNC stands for computer numeric control, and it's basically a milling machine. It's the machine that makes your iPhone. Actually, quite exactly the same thing, that Morisiki. And typically, that machine, the way it works is that machine has a door and a block of metal. A worker takes a block of metal and puts it in the machine, then the door closes, the machine then makes the part, and the worker picks up the finished part and puts it in a bin. But that's too much labor. And so now they have a Fanuc arm that loads the blank and picks up the finished part, and it works all night, all day. It's called, they call it lights out manufacturing. Because there's no need to have the lights on, the machines don't care. And the only reason that the workers have to come in at all over the weekend is because the bin where the little metal filings come out of this fills up, and they haven't figured out how to get a bigger bin. And so all they have to do is come in and take a shovel and empty the bin of filings. Takes them 20 minutes, and then the machine goes on. And this is one of the most advanced manufacturing pods in the world, and it's on 7th Street in Berkeley. And even more importantly, the designers of the furniture are 10 feet away. And so what you're looking at here is how you get fast, flexible, short supply chains. This is the way that you can link design and manufacturing. This is the way you can manufacture in market. This is the way you can make every furniture different. This is the way you can get the product to the customer 2 days after it was ordered. This is fast, and this is flexible, and this is near, and this is starting to look like a future of American manufacturing that makes sense. It doesn't create jobs the way the old manufacturing model did. It's not going to replace all the jobs we lost in the 70s and the 80s, but it does bring the parts, it does bring the manufacturing back to us. But more to the point, it brings a different kind of manufacturing back. This manufacturing is extremely efficient in that as well. Here I've got forgive me the bullet points, but this is what's different about this kind of manufacturing. You can change it every day. You can change the design by the day. You don't have to order huge batches of the same thing. That mass production model that's driven manufacturing for hundreds of years, it's all about one size fits all. It's all about finding out what the lowest common denominator, the mass wants, because that's the units that kind of, if you're going to ramp up a factory and fill the containers and put them in the trucks and get them on the shelves of Walmart, that's like a year-long process that involves units of millions. And that's great for spoons and things like that. But what about everything else? We saw what the internet did to mass media. We saw what it did to one size fits all. My first book, The Long Tail, was all about that. We recognized that once we liberated the ability for small batch and micro and niche, that suddenly we realized there was demand for things that were not, the blockbusters and the prime time and the bestsellers. There was demands for things that defined us as individuals, that didn't just define us as a group. And now we can apply that same model to physical stuff because the means of production are now as flexible and as unique as our own taste. Let me give you an example. My company, we used to make a lot of stuff in China, and we learned that there's basically 4 terrible things that happen. We used to live in China, and I'm a huge Sinophile, and I have massive respect for the Chinese manufacturing model, which I'll talk about in a minute. But as a customer of it, I realized that there were some intrinsic limitations. The first is that it's really oriented around big batches. Like we were making circuit boards. You kind of got to do. Basically, it don't get any kind of decent pricing or economics for less than 5,000. You really want to go up to 50,000, et cetera. What that means is that all of your cash goes into the supply chain. You basically have to write a check for 50,000 of them before the factory spins up. Only then does it show up. Months later, it comes. And you get it, and then you can get the product into the marketplace and get the money back. But all your cash goes into the supply chain ahead of time. The second is that it is, as I mentioned, slow. And it was good to hear that we're on Chinese New Year. Happy New Year, everybody. The tech industry is shut down for 2 weeks. Anybody who's in the hardware business right knows the Chinese New Year is the worst 2 weeks of the year because we're so dependent on Shenzhen and the Guangdong, production, world. And we know it's in the calendar. We know when Chinese New Year is, and every year we get it wrong. I mean, our own orders went in. We thought 4 weeks before Chinese New Year was sufficient to get in before New Year. It turns out that everyone else was going in 6 weeks before, and it's just, every year we get 2 weeks to remind ourselves the costs of globalization. The third problem is that if you made a mistake, if there's an error or a defect, you've just made a big batch mistake. And you've got now 50,000 of these things that you either have to throw away or rework. And so there's an entire industry of factories that will rework the mistakes of previous factories, which is tough. But the worst, and this is the most corrosive, pernicious consequence of that kind of outsourcing, is that it is death to innovation. Because think about it. Let's say you just designed some widget, okay, and you've now put it into the outsourcing thing, and because of the economies of scale, you've got to do 20,000 of these to get any kind of decent pricing. and you wait months to show up, and now they've showed up. You need to sell them, and you need to get the money back. And you can't change the design until you've sold out. So basically, you're disincentivized to innovate until you've sold your first design. And so what this whole thing does is it basically sort of says, don't change a thing. Don't change a thing because you got to sell the old thing. So big batch means slow innovation, and that's just not the way the world works today, and that's definitely not the way the web works. So, what we're talking about is shorter supply chains. I realize it's kind of wonky, but shorter supply chains are really cool. They're faster supply chains, they're more flexible supply chains, they're more sustainable supply chains. You're only making what you need, you're doing just in time. You're not shipping things 9,000 miles around the world, so they have lower carbon footprints. Short supply chains are a good thing. We've seen what short supply chains mean for food. That's why we have the locavore movement and artisanal, and the reason we go to the farmers market is because we like short supply chains in our food. We like short supply chains with our media. That's why we have the web. It's one click across to the server. And short supply chains are all equally good for manufacturing, just hard to do until recently, until we managed to make things digital and take the labor component increasingly out of it. So that takes me now to the maker movement. And I wanted to, this is Maker Faire. A quick show of hands, how many people here have been to a Maker Faire? Yes. Great. So I almost don't have to tell you anymore. It is a fantastic experience, and every time I go and run the booth, I'm just kind of like, who knew? I mean, the garages of Silicon Valley open up, and everybody's doing cool stuff, and the kids are doing cool stuff, and it's just inspiring. And it's great that it's physical stuff as well, because turns out that was all happening behind those closed doors. We just didn't know it because we didn't work together. We didn't do it on the web. So I'm gonna tell a story. But while I'm telling a story, I'm gonna ramp up this machine. This is actually I'm gonna go back to here. At the first Maker Faire, I saw my first 3D printer, and it was called a cupcake from MakerBot. And by the way, Neil Gershenfeld from the MIT Fab Labs is here tonight. And Neil, you want to put up your hand? Neil is sort of the intellectual godfather of the whole concept of fabbing, of personal manufacturing, desktop manufacturing, and 3D printing, and all this kind of stuff. I read his book, Fab, when it came out, and was blown away, but I didn't have one until I went to Maker Faire and I saw a MakerBot. So this is a MakerBot which came out of the open source hardware movement. It was largely enabled by the fact that a patent expired. And then there's things like Arduino, the open source computing platform. This is, I have the first MakerBot. I have like number 380, which is a cupcake. And those days it was a bag of parts, and you put it together. And let's just say that I never actually got it working. But this is a second generation MakerBot called Thingomatic, which still has some sort of, you can still see some of its heritage. It's still laser cut, and it's kind of screwed together. I actually did not put this together. Somebody much more competent than me did. And this one actually does work. And to be honest, I'm gonna take a big chance here, and I'm gonna try to make, while we're sitting here. Okay, I'm gonna try to make the classic 3D printing object, which is Darth Vader's head. So right now it's going through a calibration and heating process. This is my children's MakerBot, and we'll talk a little bit more about it. But this sort of reminds me a lot of the whole Maker Faire experience, which is to say it is not as shiny and polished and professional as the commercial products, but it's mine. And I'm going to do something different with it, and I'm going to think about the technology and find some use for it. So what this machine liberated in me was a memory. And that memory was of my grandfather. This is Fred Hauser. Fred Hauser was a Swiss immigrant to Los Angeles in the 1920s and 30s. He was a kind of a very undistinguished Swiss engineer. He actually never had a college degree. And he became something of a refugee. He couldn't see a career for himself there. By the way, this is heating up. It's got to heat up its tool head and its build platform. And once it heats, it will do its thing. He came to the United States for opportunity. And so he went to Los Angeles to work in Hollywood, which was a mechanical business in those days. He worked for MGM, working on the talkies, the first loops for tape, for audio tape. And by day, he cranked gears in Hollywood, and by night he invented stuff. And this is him at his work table, and he was super happy there. He's kind of a quiet guy, but he loved to take his ideas and make them real. And he did it first on paper, and then he made a prototype. And what he invented, my grandfather, was the automatic sprinkler system. So if you have an automatic sprinkler system, I have my grandfather to thank. It's the one, it's the little wheel that with the little pegs that go in for the hours, and it goes off when the hour comes. And this was the first one, and this is something that's on our wall in our house. And this is something he had a very kind of mixed feeling about. This is his patent, 1949, if I'm not mistaken. This is the patent for the automatic sprinkler system, and this was something that he felt was basically the best thing about his life, and in some ways the worst. The best thing about it is that it recognized that he in fact had invented this, and he had the full authority of the U.S. government that gave him this badge of recognition. What he hated about it is that it was a pain in the ass. He had it was lawyers, it was expense, it was time, it was a completely unnecessary process that he was forced to go through by the limitations of the 20th century manufacturing model, which is to say, if this ever wanted to see the light of day, he was going to have to patent it so that he could license it, so that a company with a factory could make it. And this is the way it came out. It was the Moody Rainmaster. It allowed you to go to the beach while your garden watered itself. By the way, when you think about this, if you imagine, Los Angeles in the 1950s, for example, they're greening the desert. They finally got the water, they got the irrigation, everyone wants the green lawn. People would come home, and they'd already invented those kind of cool sprinklers that go like that, but you had to turn it on. And what would a Swiss engineer do when he saw that? A Swiss engineer would put a clock on it. And that's exactly what an automatic sprinkler system is. So this liberated you now to get in more sun time. And this picture sort of fills me with a little bit of shame. And I'll tell you why. I would spend my summers with Grandpa. And one of the last summers I spent with him in the late 70s, so this thing is now going to do the raft underneath this, our Darth Vader head. And so in the summers, I would visit him, and one summer he took me to the factory that made the Rainmaster. And we drove there, and it was clear they had no idea who he was. Eventually, somebody was found who knew who Mr. Hauser was, and they said, "Oh, Mr. Hauser had the patent that we licensed to produce the Rainmaster." And they gave him a tour. And it's clear he'd never seen it before. He had no idea what was going on. They explained it to him very carefully, and they're very polite. But I felt embarrassed. I felt ashamed of my grandfather because he seemed lost in the modern world. He seemed to have lost touch with his invention. He seemed to have basically lost some essence of this. It wasn't his product anymore. It was somebody else's product. They had productized it. They'd commercialized it. They'd changed it. They'd modified it as one would. They'd done all the normal things of taking invention and making it real, except for he didn't do any of them. And what I realized there was that he was an inventor, but he wasn't an entrepreneur. And at that point, I felt that was not a path I wanted to follow. He had lost control of his invention. And in losing control of his invention, he had lost touch with the process of invention, because it's more than just the idea. It's more than the prototype. It's everything else. And you weren't allowed to do that then. This is how I would spend my summers with him. This is me at about 5 or 6, learning how to invent mechanical drawing with Grandpa. And this is me at 12. Check out the jeans jacket. And this was a great moment. I'm at 12, and this summer, Grandpa had said, "When you come to Los Angeles this summer, we're going to make an engine. We're going to make a gas engine." And I was like, "Cool." He said, "I've ordered a kit." So we got there, and there's a box, and I open it up, and I know what kits look like. There's going to be, the tree with the parts, and it's got numbers and the glue and the instructions, and it's like, inside the box were 4 blocks of metal and a blueprint. And I was like, "Where's the engine?" And he's like, "It's in there. We're going to get it out." And just like a sculptor cuts away the bits of this marble that aren't the figure, a skilled machinist like my father in his machine shop could carve away the bits of metal that weren't the piston or the cylinder, and out of that, from a blueprint and a block of metal, could come a beautifully machined engine. The reason I remember this particular moment is that I was doing the piston. He let me do the piston, and he showed me how to use a micrometer to measure it. And about 2 minutes after this picture was taken, he will discover that I did not, in fact, know how to use the micrometer, and that we just cut away too much. And we had to get another block of metal and start from scratch. And the lesson there was, for me, it's not enough to have an idea. If you want to become an inventor, if you want to make something, you need to be a machinist. You need these incredible skills. I mean, a metal lathe is a beautiful thing in the hands of a skilled craftsman, and as the curlicues pile up around your feet, and these polished devices come out of this machine, it's a marvel to watch. But I didn't have those skills. I would never have those skills. He was trained in that. I wasn't. So I forgot about that. This is a movie that was a reminder of why you should, why we all forgot about that in the 20th century. This is called Flash of Genius. It came out a few years ago. It's about the invention of the intermittent windshield wiper. This is the one that pauses. It had a little timer circuit. And it's a very similar, this is the guy, this is the fictionized version, but there's the guy and his kids, and there's the prototype, and he's got the commercial windshield wiper, and then a little delay circuit. And he's invented something. And then he makes this, mistake. So he's just like my grandfather right up until then, but then he does something my grandfather didn't do, which is that he chooses, although he patents, he chooses not to license. Instead, he decides he's going to make it himself. And what that meant was building a factory. And what that meant in those days was 6 years of agony. He mortgages his house. He rents some space. He starts bringing in the forklifts and the production lines and hiring people and the production machinery. 1961, 1962, 1963, and if my memory serves, it was 1964 in the movie when he is leaving the factory still unfinished. He's in Detroit. It's raining. He walks out the door, dejected, turns the corner, and sees the new 1965 Mustangs being driven to be unveiled for the first time, and their windshield wipers pause. And he realizes his idea has been stolen. And the movie then tracks his descent into madness, and it's very entertaining. And in the end, he sued for $1 bajillion and was okay, and he recovered from his madness and all that. But the lesson was clear. Don't you dare be an entrepreneur in manufacturing. You inventors don't dare to try to own the tools of the means of production, because it's expensive and the big guys will kill you and you'll go insane. And that was hard. And that was because it was really, really hard to make stuff back then. And the point is, and what I was reminded, and what I remembered, and what I kind of learned when I got my first MakerBot is that suddenly it's not that hard anymore. When I have an idea, I don't need to know how to machine plastic or whatever the right equivalent would be. I just push a button and out it comes. And okay, maybe plastic's not so impressive, but I can push another button on the web and it can come out via a service like Shapeways, and my idea can be produced and prototyped in titanium or stainless steel or silver, or at any resolution or color. And now suddenly that big barrier to entry in making physical stuff, which was the skills to prototype, has disappeared in the same way that the barrier to publishing, the ability to typeset, disappeared with PostScript and the laser printer. And that was a big deal then, and that's a big deal now. And so you will not be impressed by my green Darth Vader head if in fact it does come out. But you will be impressed by the one after that, that's going to be in multiple colors, and the one after that that's going to be in multiple materials, and the one after that that's going to have the electric wiring embedded, and the one after that, which is possibly indistinguishable from a manufactured good, and the one after that will be biological, and we can talk about that later. But that was hard, and this is not. This is what a factory looks like today. This is a tech shop down in Menlo Park. There's one in San Francisco just a few blocks from here. There's one in San Jose. They're spreading around the world. This is the gym for manufacturing. In the same way that you go to a gym and for $100 a month or whatever, you have access to machinery you wouldn't otherwise afford or want in your home. You have access to trainers, and you have access to other people who are doing the same thing, which is inspiring. This is a gym for making stuff. This has the 3D printer and the CNC machine and the laser cutters and the CNC embroidery and the CNC quilters. If you've never seen a CNC quilter, it's an amazing thing. There's one just down the street on 7th and Mission, 7th and Howard. And the software tools to use them, and also the traditional manufacturing of the metal lathes and all this kind of stuff, and the electronics tools, and the injection molding, and it's just stunning. I mean, I warn you, if you go into there, you will be tempted to quit your job. As a matter of fact, I did. So what's interesting about this is I just want to kind of point out a couple people because I like them in this picture. The guy here in the front here is making a wireless control module for the smart grid, the electric grid. And when he's done with these small batch, he puts this label that says ABB on them. And that's because it's ABB, the Swedish engineering firm, and they're actually the ones who distribute and sell it. And when you buy it from ABB, you assume it's made in some massive Swedish factory, if that's possible. But in fact, it's made by this guy at Tech Shop. And if he needs to make more, he'll just outsource it to the world's factories. The guy back there is doing a vapor deposition chamber for synthetic diamonds. And way in the back, under the American flag, they're doing a lunar lander because why not? So that's starting to look kind of interesting. The tools, these hard things, are becoming easy. This is a map of makerspaces around the world, or hackerspaces they're sometimes known, and they're spreading all over the place because, again, it's getting easy. Easy is not to be underestimated. Easy is liberating. Easy taps the pool of talents and ideas out there that were turned off by hard. And what's cool about this, especially the new versions of this, is that they're easy. And that's why they're powerful. So I showed you this picture. I showed you the analogy of democratizing the tools of creation, democratizing the tools of distribution. Now this is the manufacturing equivalent. This is what desktop manufacturing looks like. Yes, this is the new MakerBot that now basically is like a microwave oven. You just open the box and it just works. And that's great. We now can make one of something or two of something in sort of some rough coarse resolution. Call it somewhere between the dot matrix printer and the laser printer of manufacturing. That's not sufficient. That doesn't change the world. That is not an industrial revolution. It's not even a manufacturing technology. They call them rapid prototyping tools for a reason. They're prototyping tools. So how do we get to an industrial revolution? Remember PostScript. What PostScript had was fundamentally a language, a digital language that could drive the machine on your desktop and the biggest factories in the world. And now we have it. What's driving this machine right here is something called G-code. And G-code is the PostScript manufacturing. That G-code will drive a 3D printer, it'll drive a laser cutter, it'll drive a CNC machine, it'll drive all these digital manufacturing tools. And what's great about this is because it's digital, it is unencumbered by geography. You can upload it to the internet and you can share it. You wouldn't actually share G-code, you'd share a higher level language. But the point is, these are digital files. And digital files start to act like the web. And once they act like the web, they tap the innovation model, the social model. They tap everything that's been so magical over the last 20 years. Once manufacturing becomes digital, it becomes social. That's the breakthrough. So on the right here is what you do with it. So I mentioned that the guy in Tech Shop was making a few of those wireless control modules. But that's, again, he's not competing with the Honeywells of the world. How would you do so? And the answer is cloud manufacturing. What I'm showing here is a picture from a company called Alibaba. And I want to quickly sort of go through this. Alibaba is a kind of a web interface to largely Chinese factories. And what you can do is you can upload a file to the factory, and they'll make stuff for you. As I mentioned, I used to live in China, and I can tell you what it used to mean to get stuff made for you in China. You had to fly to Hong Kong. You would have to then get an introduction to factories, cross the border. The minder or your introducer and maybe translator would then take you to various factories. There'd be these really awkward conversations where they weren't quite sure who you were and what you wanted, but they'd give you a little tour, you'd drink some tea. If things went well, you would then go and have dinner. At that point, because you're the guest of honor, you would have to eat the fish eyeballs. Then, if that went well, you do the ultimate hazing ritual, which is karaoke. And if that went well, they would agree to do business with you, which required a letter of credit, some bank transfers, and that was the easy part. Then you would have to figure out what it is you're making. And this exchange of faxes and miscommunications and errors and mangled products, and months would go by. But after you were done with all of that, ultimately you could get the world's factories working for you. So my experience was with Alibaba was a little different. With my kids, I made a little sort of robot blimp and kit, and it was kind of cool. And somebody and we got Make Magazine, who has the Maker Fair, and had a store called the Maker Shed, and they agreed to buy some. And so I think we got them 10, which we made by hand. And then they said, "Terrific! Now we'd like 500." Turns out this is like the sort of like the whoops moment for all makers, is that when they become successful. And you realize that you cannot sell a kit affordably if you're buying the parts retail. You have to buy them wholesale. Duh. So I said, well, I got these motors. I got these 2 motors right now. They cost $7 each. I'm trying to get the whole kit to be under $90. There's no way I can make this kit. I have to buy these motors wholesale. So I went on Alibaba to look for wholesale motors. And I found this place that did it, and I said, I'd like to buy some motors, please. And they're like, yeah, what kind would you like? And I'm like, well, what do you got? And they're like, what would you like? And I'm like, what do you mean? And they're like, well, please design your motor. And I'm like, I know nothing about motors. And they're like, that's okay, here's these check boxes. You know, what kind of shaft length and windings and what voltage and what kind of magnet types. And I was like, check. They just coached me through it. Check. They said, fine, how many would you like? And I said, I don't know, 500? And they're like, okay, you could have 500, but here's the pricing for 5,000. I was like, that's pretty good pricing. I'll take 5,000. And then they took PayPal. And 14 days later, this box arrives at my doorstep. And I open up this box, and in this box, I had chills. There were 5,000 motors. And I was just talking to Xander, actually. He had a recent experience. My experience, he also just got some motors made in China. His didn't end up quite as well. But we'll talk about this in a second. I'd never actually seen industrial packing before. But there was these little sort of foam divots, and they were all lined up. And there was this slight film of oil over them because they'd just come off the CNC machines. These little sort of line of plastic, and there was just layer upon layer upon layer of thousands of motors. And I looked at this and I realized that I'd gotten robots in China to work for me, and they took PayPal. And I thought, holy crap. I just harnessed the means of production. I'm not a company. I didn't have a letter of credit. They didn't know who I was. They didn't care who I was. I didn't have to fly to Hong Kong. I didn't have to send faxes. I just clicked on the web for 20 minutes, and I didn't even know anything about motors, and they worked for me. And if I can do it, anybody can do it. And at that moment, I realized the global supply chain had opened to the individual. That for a number of reasons involving web generation coming of age in China, digital manufacturing, making it ultimately flexible. The reason they could make those motors for me is that because it was all made by robots, everyone could be different. And the fact that they saw that there were better margins on small batch manufacturing, and that serving individuals via the web was a better business than chasing thin margins in mass production, that suddenly the world's factories had gone on the web, and now we had cloud manufacturing. And today there's sites like mfg.com and others that do this, but this is kind of cool. We've closed the loop. We now know how to make a few, and we know how to make many. You can print local on your desktop, and you can print global. Through the world's factories. And just in the same way that when you press publish in your browser, you're getting industrially sized server farms at Google to work for you, you can now get industrial sized manufacturing facilities to work for you with a click of a button. And we are very close to the day when manufacture is a button in your web browser. So this is why this is a big deal. Because we've seen what happens when we democratize technologies. We've seen what happens when we put power in the hands of regular people. That's called the web. That's called the personal computer. It's a big deal. But manufacturing things, making stuff is a bigger deal. And we now have the opportunity to take all those social models and innovation, mechanisms and architecture of participation and collaboration and community that has worked so well in digital space and now apply it to the physical space. And that's why I quit my job. So, I told you my grandfather invented the sprinkler system. And as I started exploring this, I said, what would Grandpa do today? If my grandfather was alive today, what would he do differently? How would you invent the sprinkler system today? Now, somewhat awkwardly, we don't really have much of a garden, and I actually didn't know anything about sprinkler systems. I had to go under the house and sort of look at it just to kind of learn, well, this is a valve, and that's a solenoid, and anyway. But Grandpa did a sprinkler system, so a sprinkler system it must be. And rather than just think about it, I decided to do it. So I said, okay, we're going to invent a sprinkler system the maker way. So I kind of Googled around and found there were a couple other people who were doing this, and this is it. This is it, Open Sprinkler. It's an Arduino. It's connected to the web so that if it's going to rain tomorrow, it knows that and it's not going to sprinkle today. You can add all the sensors you want to it, and there's no subscription fee, and it only costs $70. And you can turn it off with your smartphone or your web browser from your desk, and you can change it and make it better if you'd like, because it's all open source. And now, this is not the best sprinkler system in the world. There are better ones out there. But this is mine, and this was done in about 6 weeks. And the fact that I could do what my grandfather never did, which was go from idea to marketplace in 6 weeks, and with a better sprinkler system that sort of did, in fact, update the automatic sprinkler system for the 21st century in my own little way, was kind of amazing. And what was even more interesting is it turns out the main market for this is hydroponic pot growers, who turned out to be, they have very intense sprinkling needs. Also an underserved community, I'll have you know. So there was that. Now, this was only a thought experiment that I decided to make real, but in the course of doing so, I had to make the enclosure. And this was another thing I knew nothing about. You remember when we made a dog's breakfast of fonts and such with desktop publishing? Well, this is me making a dog's breakfast of CAD. And this is my first CAD experience in this enclosure. It turns out, by the way, the walls were way too thin. But I downloaded a free program. It was called Autodesk 123D. It's now released as Autodesk 123D Design. But this is my very first experience with CAD. And it took about 3 minutes. And I just want to kind of point out one thing, which again, this is like the next thing that I got chills. Okay, so I told you that desktop publishing was amazing, whether you remember that or not. Here's something else that's amazing. Okay, this is not going to impress you, but it should. When you go to your word processor menu, and you go to the File menu, and you pick Print, and bits on the screen, pixels, turn into atoms of ink through some miraculous process of parsing and vectors and rasterization and God knows what, when you press Print and out comes the piece of paper, that's kind of magic. Bits turn into atoms right there in front of you, and it looks beautiful, and sometimes in color. Anyway, okay, you're not impressed. With CAD programs, you don't pick File, Print. You pick File, Make. And at that point, when you pick Make from these, what happens is that 500 years of manufacturing skills and expertise and technology gets turned into a software wizard. And it sort of says, well, would you like to print that in 2D or 3D? Would you like to print that here or there? On your desktop or using a cloud service? What material would you like? Here are the cost implications of this material versus that material. Oh, you would like to print in titanium. Here's a way to minimize the volume to cut down the cost. Oh, here's some of the various sourcing types. Would you like to bring electronics into it? It kind of, we've turned like the global supply chain into an algorithm that's on your desktop. And we're coming very close to the day when manufacture is, in fact, a button in your web browser. So check it out. These things are free. If you have your phone, you can download it on your phone. 123D Design, it's on iOS, and your iPad, and on your desktops, on Macs and PCs. And it's free, and it's super easy, and manufacturing is now a button click. And that is kind of awesome. So what does that mean? That means that in the same way we all became publishers, we are all now designers. And it's time to get good at it. What does it mean to be a good designer? Well, CAD used to be hard, right? CAD used to be like $5,000 a seat license. You had to go to school to use, by the way, CAD is computer-aided design. It's like the word processor of 3D images, of 3D objects. You had to go to school and get training and permission, and only companies would have CAD and architects and such like that. And now, everybody has CAD. You've got CAD on your phone, whether you're using it or not. If you use Minecraft, the game, that's CAD. Doesn't look like CAD, but it is CAD. Our children are growing up. They're fluent in polygons because they play video games. They know how to translate from 2D screens into 3D imageries. They can navigate virtual space. They're good at this stuff. This is second nature to them. But it's just CAD. It's all the same thing. It just was called this scary thing called CAD rather than designing stuff or drawing. So I'll tell you, I want to finish with a story of my children. My wife Ann is here, and she will hopefully forgive me for once again using my children as props in my speech. But my children, as I say, growing up with a MakerBot, and this is sort of what it does when you grow up with digital manufacturing technology in your home. We remember, by the way, what happened when this happened in our generation. So remember the home computer? Our parents got us home computers. They bought the family home computer. It probably cost $2,000. I wasn't sure why we had it. It was, maybe the program kind of seemed important to a child's education. It was a shared, device. But those home computers, we figured out what they were for. Now, some of us decided they were for video games, but others did, in fact, learn to program or create or do email or something, and that's why we're here today. That home computer changed the way our experience with technology and liberated something in us that brought us into this room. And now we have the opportunity to grow up with digital manufacturing, to grow up with the 3D printer in your home for about the same price at about the same sort of level of development. So my children grew up with a 3D printer, and my girls love The Sims 3. The Sims 3 is a video game, but it's basically a virtual dollhouse. You build a house, you populate with people, build in furniture. They love it, but at the end, they have a limit on how much video game time they're allowed. And at the end of, I think they're allowed 2 hours a weekend day, and at the end, this Hello Kitty timer goes off, and it's time to stop. And then they complain mightily about how they have to play in the real world, and we're like, you have a real dollhouse. Why don't you play in a real dollhouse? And my girls, in particular, complained. They say, well, it's not as good as the Sims dollhouse. And it needs this. Did you see I just did this cool furniture, this kind of 1950s style furniture? Daddy, can you buy that for me, please, for my real dollhouse? And I know the answer. I know the answer is no, but with parenting, you have to kind of get to know. And so I said, well, so first I decided I would at least have an informed no, so I researched dollhouse furniture. You didn't think the speech was going to go in this direction of the systematic failures of the dollhouse furniture industry, but so there's 3 fundamental problems with dollhouse furniture. Number one, it's really expensive. Like a kitchen set with 3 components is like $40. Number 2, there's very little choice. You don't get 50 styles dollhouse furniture. You get Victorian or nothing. And number 3, and this one's really crippling. There's no systematic standardization of size. So dollhouse furnitures come in all different sizes. The dollhouses themselves come in different sizes. The people are not the same scale as the houses, and they're not the same scale as the furniture either because they don't bend properly and they don't sit in the chairs. And if you get one set, it doesn't fit. It doesn't fit with the other one because there's no standardization. Rant over. So the answer was no, we're not going to buy dollhouse furniture, but we don't have to buy dollhouse furniture because we have a 3D printer. So we're going to go online to Thingiverse, and we're going to find cool furniture designs. So this was exactly the chair they wanted, but it's a lot of fun. They were delighted to see these designs. And once we found it, we downloaded it, and in the software, we did one thing, which is there's a little slider that decides how big it's going to be. And we scaled it just right for our dollhouse and our dollhouse figures, and then we printed it. And then they painted it, and they love it. And that simple act of picking up the design from the internet, dragging the slider so it's just the right size, and then painting it, turned a consumption process into a creation process. And this is no longer a Happy Meal that they're going to discard. It's no longer some toy that was bought on a shelf. This is something they made. It wasn't hard. They didn't have to use a lot of skills, but they put a little of themselves into it, a little creativity. They customized it for their own interests, and so it doesn't even sit in the dollhouse. It sits on the windowsill because they treasure this. And their relationship with plastic is fundamentally changed because it's their plastic that they made and they changed to reflect themselves. This is that design I just showed you. How did that design for that dollhouse furniture get there? And the answer is Casey. Casey is, by day, she is a set designer on Broadway. In the old days, with set designs, they'd make models first with like balsa and cardboard. But now she has a MakerBot, and she has CAD. And you can see there's her MakerBot in the background. And here's the set design. And what she does is she designs these beautiful sets for whatever play she's done. She then 3D prints them. And when the producer signs off, they then fabricate them in full size, and off goes the set. But then what to do with those designs? She's the web generation. We know what to do with our ideas. We give them away. We put them online. We share them. And so she puts them on Thingiverse. And they turn into my children's dollhouse furniture. She's not in the dollhouse furniture business. She's not in the furniture business at all. She's a set designer. But what she did had utility outside of set design. And as a result, she has liberated a generation of children, and her stuff is fantastic. Check it out. Go to thingiverse.com and check out Pretty Small Things. You will not believe her. Her space station playset is unbelievable. Anyway, that's what happens when you take the web's innovation model and attach it to manufacturing, is suddenly these great things like sharing and giving away and communities and free, thank you, Stuart, kick in. And now if you're a toy company, this should fill you with terror. Because my children don't need your stuff anymore, because they've got a MakerBot and they've got the internet. My boys, meanwhile, do Warhammer 40K mechs. So, this is, I told you that this is one tool. It's cheap and easy. I told you about cloud manufacturing. It's cheap and easy. This is the other tool, the software. This is Tinkercad. It's free on the web. This is one of my sons, Toby. We saw WALL-E, the movie, and he thought that it'd be cool to make a Toby robot. And so this is what he does for fun. This is kind of amazing. So kids now do CAD for fun. And he doesn't know it, but he is that digital designer. And he is getting good at it. And he now knows that anything he can imagine, he can make real. And he knows that it's easy, and he knows that it's free, and he knows that there's no one who's going to judge his designs. And there's no one who's going to say that's not good enough, or you need to be a professional, or you need to go to school to do that, or you need a credential. In the same way that no one judged us when we published via blogs, or when we tweet, or when we used the internet, we could do what we wanted, and that liberated the creativity that defined the last 2 decades. So I want to end just on this one note. This is the last bit of history that should have blown your mind at the time, maybe did blow your mind at the time, but probably doesn't blow your mind today. When Apple released the iPod, the motto was rip, mix, burn. Remember that? Rip, mix, burn? What does that mean, rip? It means take a manufactured good, a commercial good, and make it your own. Digitize it, bring it into your computer. Mix, change it. Burn, remanufacture it. Create your own CD, your own DVD. Okay, I get it. It's just ripping music and burning CDs, and what are CDs anyway? But still, it was kind of unbelievable in its time. Autodesk has a similar slogan, which is kind of unbelievable in its own way. Rip, mod, make. What does it mean to rip physical goods? It's called reality capture, 3D scanning. 3D scanning is a process by which you use a technology to digitize, to scan an object and turn it into polygons. Again, it used to be a very expensive technology. It is in your pocket right now. If you have an iPhone or an iPad, right now, download a software, maybe not right now, but when you're out, download a free software app called 123D Catch from Autodesk. And what it does is it uses the camera, just like you can see here. You use the camera on your phone or your iPad. You just go around an object like that, and you go click, 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 click. It uploads it to the cloud. It stitches it together and creates a polygon like this so that you can print a Pez dispenser of your head. But what that means is you could photocopy stuff. So this thing right here in my hand, I don't like it. I wish it were white, or I wish it were titanium, or I wish it had, blue horns. I just photocopy it, or my logo, more to the point. I just go click, 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 click. I've now ripped it. I then import it into these CAD programs, Tinkercad, whatever, which I can use because they're easy, and I change it. Maybe I'm going to add my logo. And then I upload it to Shapeways and have it printed in titanium because that would be cooler. And I've just photocopied reality. That's kind of amazing. And by the way, Dimension is all free? Well, except for the printing and titanium stuff, which is actually super expensive. But the rest of it, the ripping and the mixing part, or the ripping and the modding part, that's all free in your pocket on your phone. This is kind of magic. And this one, again, try it. And I suggest, by the way, daylight works a little bit better, and make sure the contrast is good. But it's kind of the fact that it works at all is astounding. There are massive questions that get raised once you can photocopy reality and make it your own. Intellectual property is just the beginnings of it. I showed you the Warhammer figures that we did. It turns out that here's my other complaint. Okay, after I complained about the lack of standardization in dollhouse furniture, here's going to be the lack of standardization in base figure ratios in Warhammers. Warhammer kits come with 11 figures and 10 bases. I have no idea why. And so my boys say, Dad, can you buy us a box of bases? And I'm like, a base is a circle. It is a disc. And I'm like, no, we have a 3D printer. We are not going to buy a box of discs. We're going to make them. And so I did this. At this point, I'm super good at CAD because I can actually draw a circle and extrude it, and done. And we printed it, looked great. And then because, in my own little sort of Casey way, I uploaded to Thingiverse and to share it. And then it came time to label it. They said, okay, it says title. And I'm like, Warhammer 40K base. Description, this is a base for Warhammer 40K figures. And I posted it. And within 5 minutes, the first comment comes in, dude, you were in so much trouble. The last time somebody did this, Games Workshop, this British company who owns the Warhammer line, filed a DMC takedown. They're coming after you, man. Take it down. So at the time, I was the editor of Wired, and I thought, this could make it for a cool story. I'm just gonna wait and see what happens. Well, nothing happened. They didn't come after me, and so I was getting kind of bored, so I went after them, and I said, hey, Games Workshop, see what I did? I posted this. What are you going to do? I was a little nicer about it than that. But, and they said, I said, it's just a circle. Are you really claiming intellectual property or, rights over a circle? And they said, what'd you call it? So I called it a Warhammer. Oh, yeah, well, that's a trademark name. The moment you called it a Warhammer 40K base, you're infringing our intellectual property because that's our name. And I'm like, oh. I mean, you're acknowledging you've ripped us off. The moment you titled it the Warhammer 40K figure, and I said, oh, okay. Then I looked at what other people did, and what they all did, everybody else did, and there's tons of Warhammer 40K scan stuff out there, and they all did, it's like base for board gaming figures, and then the text it says, this is a base for board gaming figures. Do not use it for Warhammer 40K. If you want to use a Warhammer 40K base, buy it from Games Workshop. They're the best. And you know why they type that, right? So that when you type Warhammer 40K into the search terms, up it comes, right? So let's just say that that we have not completely figured out what intellectual property is going to mean. By the way, you cannot copyright physical stuff. You can copyright words and text and video and music, but you can't copyright physical stuff. We actually don't have laws to decide this. We don't know how many polygons is intellectual property infringement. Is a low poly photocopy of reality okay, but a high poly not? What if I give it away? I know what happens if I photocopy Bugs Bunny or photocopy Mickey Mouse and sell it. But what happens if I photocopy Mickey Mouse and give it away? I don't know. I mean, I'm sure I do know. I get sued to death by Disney. But I don't know on what grounds they're going to do so, and no one else does either. The fact that copyright does not apply to physical things is a massive challenge now that we all have the ability to rip, mod, and make. I'm actually going to skip. I think I'm running past this, so I'm going to skip past the last part, which was my own little story and just end up with this. This is kind of like my slogan. This is my bumper sticker of what's going on. And it is atoms are the new bits. And what I mean by that is that the magic of what we did on the web, and the magic of what we did with personal computers, and the magic of digital now applies to the physical. If you thought the web was big, I think this is going to be bigger. Thank you very much. Thank you.
Let's go sit.
I'm going to get my water.
Oh, good idea. I'll share. You're supposed to sit there.
I will.
You hardly mentioned open source. How's that play in all this?
Open source is my particular passion, but I don't think it's actually required. I mentioned that I mentioned a couple things that were actually open source. Arduino, which is the computing platform that we use for OpenSprinkler and for all of our drones, which we may talk about later, is an open source hardware project. MakerBot over there is an open source hardware project liberated by something called the RepRap project. How's my Darth Vader head going?
Taking its sweet time.
Taking its sweet time. Yeah, this is why this is not a mass production technology, right? We'll get there. The jaw is fully in place. So open source, as you know, and all of you know very well. I mean, you had the first open source conference, I guess, didn't you? No, but you were there.
The Hackers Conference?
Yeah.
Hackers Conference is that.
Okay, so open source is a very explicit form of sharing, which is to say it comes with a license that requires, that everything that's derivative designs be also shared. And that's a very kind of hardcore form of sharing, which I believe in, and everything we do is open source, but it's not required. That, there's other forms of sharing. Creative Commons is a form of sharing that's not explicitly open source, and sometimes just sort of giving away stuff with no license whatsoever is okay. So I think that open source is open source hardware is an interesting experiment on the kind of the hardcore side of what I'm doing, but it's not, the maker movement is not, and open source are not synonymous.
So a question from Bob Kopek. What can't you make? What shouldn't you make? Ball bearings? Nano stuff? Can you make nano stuff yet?
Well, so when I say me, let's just say the tools available to me.
The phenomenon.
Yeah. So actually, I mean, Neil's here, and Neil just headed off, so I'm going to have to answer for him because he's the expert on this. So here's what we can make right now. We can make relatively, high-resolution metals, plastics, glasses, woods, and things like that. We can start to make them in multiple colors, so it starts to look like, properly painted thing. And we are just beginning to make them out of flexible materials and be able to have wires inside. What we can't yet make is like the semiconductors, the chip inside it. We can't make multi-material things to have like the metals and the plastics together in the same, pre-made in the same thing, and and we can't make them. We can't make them in many copies. So this prototyping technology is slow, as you can see. Once you move into mass production, you actually have to switch to a whole different sets, and now you're going to go from 3D printing to injection molding, and maybe from the CNCing to casting, and maybe from the the printed wires to circuit boards, and you actually have to switch technologies when you go from micro to mass. But as furniture factory I showed you, once the machines get better, then actually digital does start to scale. So that's kind of where we are right now. Here's where we're going to be. So I think we're kind of in the dot matrix period. We're about to get to the laser and then the color printer, etc. We are going to get multi-material. We're going to get the electronics. We're going to get resolutions indistinguishable from the mainstream, from mass production. After that comes biology. Craig Venter, the biologist who you know very well, is working on a desktop DNA printer. And the scenario is this, or RNA printer, if you will. And the scenario is this. I know Ryan's in the audience, and she'll be horrified, or probably knows all too much about this. But so right now, we had flu season, and probably many of us got our flu shots. Did you know that flu shot was a guess? It was a guess based on some calculation of what the swine-human exchange was in China months earlier, and the guess is righter or wronger at any particular time. What if, rather than that, rather than the flu shot months in advance that's a guess, possibly wrong, what if you got an email from your doctor, an encrypted email, let's say, that says, this is the strain of flu that's actually arriving right now. This is the virus that's hitting your town next week, and send this to your RNA printer and print out a little vaccine, a little goo which you'll put in your orange juice or whatever and drink. You would have a custom, just-in-time vaccine that was absolutely right. Now that would be good for the flu. It sort of raises the question, what could possibly go wrong? So right now, if you want to, so this basically it's called DNA synthesis. And DNA synthesis is now about this machinery is about the length from here to the podium, but it's getting smaller every year, and pretty soon it's going to be the size of that. Right now, we stop people from synthesizing smallpox by the fact that there's only about a small number of firms that do a DNA synthesis, and they look for that. What if everybody has one? How are we gonna, how are we gonna stop that? That genie's out of the box. You can't stop me from making something because it's open source technology.
What I like is the FBI is a lot hipper than they used to be. Back in the days, they'd lock up every hacker that they could identify. Now they go to the, basically IGEM and biohacker meetings, introduce themselves. I'm from the FBI. I do weapons of mass destruction. If you see anything weird, will you let me know? Here's my phone number.
Sure, that's probably the way. It hasn't stopped the hackers.
Well, of course not.
Yeah. Well,
the weirdness is coming. Here's an element that I'm hearing about. So DIY Bio, Jason Bobe, doing this thing in Boston. And Ryan and I were asking, so, what's the sort of level of innovation you guys are really dealing with? And he said, what we do is trailing edge innovation. Yeah. And what you're describing here has very much that quality.
Absolutely. There is
trailing edge innovation. Now, what is, this sounds like Buckminster Fuller talking about, the rudder is the main event, actually, and it's after the ship has gone by, there's a rudder and then there's a trim tab. The last thing that happened is actually what's controlling where the ship goes. Are you saying with the trailing edge technology, the trailing edge innovation is going to turn the ship?
I am a huge fan of trailing edge innovation. So the personal computer was not the most powerful computer, right? It was probably the least powerful computer, but it was the only one you could buy. It was sitting behind the glass wall, the glass room. You didn't need to be an IT guy. You needed to be a corporation. You could own it. So the great thing about trailing edge technologies is that they are accessible technologies. And the most powerful thing about technologies is not what the technology, it's who uses them. We put more drones in the air every quarter than the U.S. military. Our drones are not as good as the U.S. military.
We're all disappointed you didn't bring some drones to hover in the auditorium.
You didn't ask. Next time. Plus the small fact I didn't want to kill anybody. It's not with weapons. Not with weapons. With sort of out of control robotics. But our drones are not as good as the U.S. military ones. But you're not going to get a U.S. military one. And you're going to think of non-military functions, and you're going to think of in the same way that the internet used to be military, and then we found better use for it once it became ours. You remember we started, the military internet was on broadband. Ours was dial-up modems, but we did magical things with them. And the personal computer was not powerful, but we did magical things with them. And this is a terrible 3D printer. But my children or other people of their generation will do magical things with it because trailing edge technology is democratized technology.
Okay, here's a question, since it's coming from Lee Felsenstein. I'm particularly interested in it. Has the first killer app for 3D printing yet appeared? If so, what is it? If not, what do you think it'll show?
That is a great question, Lee. I get asked that all the time. I wish I had an answer. So I think the way to answer this is like saying, first of all, it is not unusual for people at this stage of technology not to have an answer for that. I'm sure that Jobs and Wozniak didn't know what the personal computer was ultimately going to be for until the spreadsheet or the video game or whatever came out. And there may not be one killer app. In my house, dollhouse furniture is a killer app of 3D printing. But let me give you an example. So when the color printer, desktop color printer came out, what was it for? The answer was to print your fonts in color, right? And that was not terribly compelling. And then we invented the digital camera. And now we know what it's for. It's to print our photos. And at the time, remember at the time when those first printers came out, people thought you were going to print the New York Times? It was going to be distributed manufacturing of mass media. And they certainly thought that we wouldn't all be creators, we wouldn't all be writers, we'd be printing out other people's writings. And that turned out not to be true. In fact, we are all writers, not necessarily printing it out, and what we end up using our printers for is stuff that we create. Not because we're painters, but because we have cameras, and we take our own pictures and print our own pictures rather than downloading and printing other people's.
How many here still print photographs?
Okay.
Well, there's, maybe 20. Question from Rob Knapp.
Precious memories.
What will be the immunological response of established large-scale manufacturing to the presence of this alien form of making things? How's this playing in China, for example?
First they ignore you, then they laugh at you, then they fight you, then you've won.
Right.
So, I mean, we're kind of in the ignore phase, I think. I think the maker movement in particular is, and these things are dismissed as toys and insubstantial. Here's my new watch. This is my Pebble smartwatch. Anybody here have a Pebble smartwatch? Okay, pretty cool. Have anyone heard of the Pebble smartwatch? Great, okay. So this is a Kickstarter project. Kickstarter is like the financing model of the maker movement. And what I love about this smartwatch, this Pebble smartwatch, it was announced on the same week as the Sony smartwatch. Does anybody here have a Sony smartwatch? Has anyone heard of the Sony smartwatch? Okay, so
there's
one person has heard of the Sony smartwatch. I love that this was designed by 4 kids in Palo Alto. And it blew Sony away. And I just think you take a few more examples like that, a few more Pebbles blowing away, 4 kids in Palo Alto blowing, or Kickstarter projects blowing away mass manufacturing companies, and then they're going to start to pay attention.
So is this some new level of innovator's dilemma that Sony can actually figure out and get in front of?
Sony in particular?
No, Apple, say, or Google, or something.
There's been a series of experiments with companies releasing design files to allow innovation. So, for example, I don't think it was Apple, but I think Nokia released the design file of the case for a Nokia phone. And they're like, you know what? So we'd like to be cooler. We'd like to be cooler. We think the cases are kind of a way for people to express creativity around our products, maybe make them a little bit cooler. You should not have to go through the hassle using micrometer and measuring the case and doing the CAD yourself. Here's the CAD. It's out there. We've given you all the mechanical dimensions of what's necessary for a case. Now, go at it. But, come up with some cool designs or etch it out, et cetera, and make it and build a business around it, and we're going to make it easy for you. So that's a little tiny thing of releasing the design files. Nokia is not a trade secret for Nokia. It just made it easy for a community of creatives to build businesses around them. And Lego does the same thing. There's a whole ecosystem of Lego, of people doing kind of the long tail of Lego, making things that Lego wouldn't make. There's a company called Brick Arms that makes we get back to weaponry, but they make guns basically for Lego, because Lego doesn't like making guns. They're a family-oriented company, but kids like guns. And the nice thing about guns is that it keeps those. The tragedy for Lego is that their customers age out at 12. And they lose them. But if they can only keep them to 16, they buy these $300 Death Star models. So you need to bridge the gap from 12 to 16, and the way to do that is with guns, and Halo, illegal Halo figures, which Lego will not make. But there's a whole ecosystem of these small kind of makery companies that serve that market. Keep those boys in the Lego world just so that Lego can get them back and they buy the high-end stuff.
Okay, last question. These are seminars about long-term thinking. And boy, does this sound like a kind of a short now talk. Now, you did mention,
harsh words.
This is all stuff that's happening. God, you're telling us everything is getting faster, and then this week, and things are trying to catch up, this season. What's the long now aspect of this story?
I would say the long now aspect is twofold. First of all, it's the reversal of globalization. It's the fact that manufacturing is no longer driven by labor costs and instead by flexibility. So that's the future.
500 years?
Yeah. So let's say the last.
Okay, so that's flipped. It's gone permanently, you think.
So now manufacturing goes closer to market. It's driven by innovation, driven by speed, not money.
Okay.
That's kind of an Einsteinian pivot, right? From the dimensions of money to the dimensions of time. But that means that could be the future of American manufacturing. It means that we now start to make things where the ideas are rather than where the cheap labor is, and that could be, I don't know how many jobs it's going to create, but that's a kind of a millennial long shift that's going to play out. The other one I would argue is it's the long tail. It's the long tail of stuff.
What do you mean?
It's the ability. Mass no longer wins the day. At the end of the day, the markets of 10,000s. Kevin Kelly here is brilliantly written about the power of small markets. By small, it's like so 10,000. Take 10,000. This is a tough number, right? 10,000 is too big for an individual and too small for mass production. Mass production doesn't get out of bed for 10,000, and individuals can't get up there. So what about all those markets of 10,000? On the web, we know those markets of 10,000. They're called the web, right? It's niche. It's discriminating. It's focused, sites. We could do that because the web doesn't care about scale. Now manufacturing doesn't care about scale, and those markets of 10,000, which is really the Kickstarter, the Kickstarter model or the Etsy model, those markets of 10,000 can now exist. And what we're going to discover is there's a new class of product out there that couldn't exist before because they violated the scale rules that will now exist. And maybe they're just going to be better versions of the old products, or maybe they're going to be something we never thought of.
So is this a Moore's Law artifact, and will it slow down when Moore's Law slows down?
Well, yes. I mean, it is a Moore's Law artifact. It is absolutely driven by the march of technology. The fact that this is cheap and easy is basically Moore's Law. And that's great. When you say when Moore's Law slows down, you're talking about the semiconductor part of Moore's Law.
All right. There's also a biotech version, which is 4 to 6 times faster.
Yeah, I mean, in my world, in drones, what we're driven, we're driven by the technology inside your smartphone. Which is actually more about like MEM sensors and about the camera and about the GPS and about the software and the wireless, and so there's much more than just simply the processor itself. And so when you think more broadly about technology interacting with the physical world, which is what the sensors, the Internet of Things does, then I think we've just begun to touch what Moore's Law can do.
Welcome to the future. Thank you.
Thank you.
Okay.